Good afternoon to one and all. So today we'll start the first unit, that is DC circuits. We are going to discuss with this one. Subject basic electrical engineering DC circuits we are going to discuss here now. So first, after starting the first unit, unit number 1 is DC circuits, and we should have to know that one. What do you mean by DC? First question will arise: DC circuits. So the currents are classified into two types basically. Based on the power supply, currents are direct and alternating. Like that, we are going to two types of currents are there, or supplies we are going to consider based on the supply. Alternating current is nothing but AC, and direct current is nothing but DC. We are going to call alternating current is AC and direct current is DC. We are going to tell that one here. So this is direct current circuits. We are going to call that one. Is it audible? Anyone?
Yes, sir.
Yes, sir.
Yes.
So that is DC circuits is nothing but direct current circuits. What do you mean by circuit? The question will arise here. So in the electrical circuit, we have to know that one. Which one is nothing but it's a closed conducting path we are going to consider now. Closed conducting path followed by any current. That is electric circuit we are going to consider that one. So followed by any current in a closed conducting path, एक ring है उसको supply दिया तो वो circularly continuously it should have to flow over there. If एक बीच में किधर तो cut हो गए तो it is not a circuit. We are going to, it is not a closed conducting path. It will not create closed conducting path over there. So which is the closed conducting path followed by a current through it, that one we are going to call as electric current. We are going to call, if we have given the DC supply to that closed conducting path, or that closed conducting path followed by a DC current, then that circuit we are going to call as DC circuit. That circuit we are going to call as DC circuit. Just a minute. That circuit we are going to call as DC circuits. So this is the DC circuit. We'll just, I have derived the definition here now. What is the syllabus? Syllabus of the DC circuit is here. The for 3 points or 3 parts we have made this first unit here now. The first part is, that is Ohm's law. We have to discuss the statement of Ohm's law and which is related, what are the relating parts of the Ohm's law we are going to consider. Our Ohm's law is completely depends on what, that one also we are going to consider. After that one, what do you mean by resistance? What do you mean by specific resistance? What are the energy sources? What is the concept of open circuit and short circuit? These all things will comes in the first part, sub unit of the DC circuit. The main unit name is DC circuits. The subunit is divided into 3 parts. That is completely, this is a basic related things here now. Ohm's law is a basic, already you have studied. I think you may have studied this one. And resistance also you have used in the physics subject. And specific resistance, it is also related to resistance only. Is there some what we are going to call proportionality constant, we are going to consider that one. Energy sources, which type of energy sources we are going to provide to the circuit. What do you mean by concept of open circuit, short circuit, we are going to discuss in the first part of the DC circuit. Next, the second subunit of the DC circuit is completely related to the Kirchhoff's law. Kirchhoff's laws, the voltage law and current laws. Two laws are there. The statement we have to describe Kirchhoff's voltage law statement, current law statement, then its applications we are going to discuss. Applications of Kirchhoff's current law. So don't unmute. Okay, that is the second subunit of this first unit is Kirchhoff's law we are going to discuss. The third part is simplifications of circuits using series parallel combinations. So suppose 100 resistances are connected in series, 100 resistances are connected in series, उसको एक resistance करने का है, that is called simplification. Simply we can total resistance of the circuit we have to calculate, total current we have to calculate, total voltage of the circuit we have to calculate here now. So that is simplification of circuits by using series connection रहने दो, parallel connection रहने दो, or combinations of series parallel रहने दो, our star to delta connection, the star connected circuit we have to convert into delta, then by applying series parallel combination we have to simplify the circuit. Similarly डेल्टा कनेक्टेड सर्किट को स्टार में कन्वर्शन करना है, स्टार में कन्वर्शन करने के बाद सीरीज पैरेलल कॉम्बिनेशन को simplification करके again we have to calculate the one resistance. So these are the main points of the DC circuits. This one we are going to discuss here now. Nearly 8 to 10 classes it is going to take to complete this first unit here now. So very important thing for the basic for the electrical engineering, you have to remember this unit. This is very important for you people. So in all, it is not only electrical I am telling, all branches, civil रहने दो, mechanical रहने दो, computer रहने दो, or electrical रहने दो, ENTC रहने दो, they should know the Ohm's law. If you are an engineering student, you should know the Ohm's law formula. That is very necessary. You should know resistance, capacitance, inductance means what. Everything you should have to. This is the, and Kirchhoff's law you have to know that one. If simple circuits you are going to calculate, then simplifications. This is a very important. Totally, I'm going to tell that one. So the first part, what we will go, that is DC circuit. The definitions we are going to discuss here now. This is the DC circuits we are going to discuss here now. So DC circuit, a closed path followed by direct current is called DC circuit. Normal electric circuit is nothing but closed conducting path followed by a current is called electric circuit we are going to call. If the followed current is direct current, then followed by direct current is called DC circuit. We are going to tell that one here. So can you note down all these things? Take the heading, first unit, heading you take down. DC circuit, unit number 1, DC circuits, heading you take down. The syllabus already we have taken, no need to take this syllabus. Directly you take that one. Definition of DC circuit you take down and note this one. A closed, in the double inverted comma you write down this one. A closed path followed by direct current is called DC circuit. A closed path followed by direct current is called DC circuit here now. So this is the DC circuit we are going to consider here now. So it will started from, this is the voltmeter, voltage, supply voltage we are going to consider. Inside that one, negative to positive, the supply is flowing here, the current, it is also closed path only here now. So from this point positive to negative it will go here. So there is a, here the closed path is there, but it is followed by the current here now. The current is flowing through this resistance and coming back to the apply voltage, negative terminal of the voltage. We are going to supply voltage, we are going to call that one. It will start from positive terminal and it will flow through the resistance, it will come back here now. So continuously the current will flowing here now. So that is a closed path followed by which current? DC supply is given, DC current will flow here now. So that is called DC circuit we are going to consider. So there are three essential fault of any circuits are this one, DC circuits, three essential parts. First, supply voltage so required, we have to give the supply. So supply voltage we are going to call that one as supply voltage, or applied voltage we are going to call that one. कितना voltage apply किए उसको applied voltage we are going to tell that one here now. So here the resistance is there, is nothing but load resistance we are going to consider here. It may be load resistance. So it load resistance है. Here also two terminals are there. Here also two terminals are there. ये दोनों terminals को connection करने के लिए हमको connecting wires are required. That is connecting wire from this here to here, connecting wire here to here. There is a connecting wire we have connected here now. So there are three essential parts of the DC circuits are energy source. Energy source is nothing but applied voltage. Applied voltage or supply voltage, you can call that one. And load resistance, this is the load resistance, and connecting wires here. Is it clear?
Yes, sir.
Okay. Have you taken this one? Circuit diagram, and these three essential parts of any circuits are energy source, DC you write down, load resistance, connecting wires. Have you taken this one?
Yes, sir.
Everyone, you should have to note down this one. In the last file submitting, I will ask this one to scan and upload. After completing every unit, you have to scan and upload that one. Remember. Okay. Next one. This is introduction of DC circuits we have discussed now. Actual syllabus, it is starts from Ohm's law here now. Anyone, can you state Ohm's law? Any one person, if you know.
Current is directly proportional to voltage.
Current is directly proportional to the voltage.
Voltage.
Anyone, others? Other thing, other students? Any one of you can give the answers.
Sir, V is equal to IR.
V is equal to IR. Very good. First person, he has told half statement. Second person, he has told the formula, but no one is stating that one.
Current is directly proportional to voltage and inversely proportional to resistance.
Okay. V equal to IR. So I equal to V by R, you are telling that one. Okay. Both are same only. V equal to IR and I equal to V by R. Current is directly proportional to voltage and inversely proportional to the resistance. Okay. That is also simplified form in the PUC, in the Bharvi standard you have studied, I think, Stoll standards. Next.
Current is directly proportional to potential difference.
Okay. So everyone of you people, you know half definitions only. So, yes, tell me this. Still, I am not going to discuss.
It states that the current through a conductor between points is directly proportional to the voltage across its point. There equals to IR and I is equal to V upon R.
Okay, take it. But the current is directly proportional to the at constant. You have to mention that one. R is nothing but what? Resistance. Resistance of means nothing but temperature. Temperature means it has some constant, that one here now. So if we are maintaining constant, the load resistance is constant, then only V equal to IR. In the statement, you have to take down that one. Okay, we'll go for the next slide. I will display the statement. But before discussing to the Ohm's law, we know that one in a basic circuit, DC circuits, voltage is there, applied voltage, the current is flowing, load resistance are there. But these all are related to one and other. Each other, they have the relation. So they have the relationship between applied voltage, current, and load resistance in a DC circuit. It was discovered by a German scientist, that is Georg Simon Ohm here now. He has derived the relationship between voltage, current, and resistance. Later he found the definition of resistance here now. So for that reason only, the resistance SI unit is ohm only, we are going to call that one. Unit of resistance is ohm. So he has derived this relationship between voltage, current, and resistance here now. So this relationship is called Ohm's law. This relationship is called Ohm's law here now. For that reason only, he has found the relationship between these three elements. So the Ohm has derived. For that reason only, we are going to call this one as Ohms law here now. The circuit is no difference. Load resistance, connecting wire, and applied voltage only we are using here now. So he has derived the relationship between applied voltage, load resistance, and current here now. He has derived the definition here now. So this is not necessary to take that one. Next we'll go for the statement will come here now. See here. The current flowing through a conductor is directly proportional to the potential difference. Is nothing but potential difference is nothing but voltage only. The potential difference between the ends of a conductor here now. If two conductors are there, in between that one, the potential difference we are going to find here now. But what we have to do, the current is directly proportional to the voltage, you have told all of you, but you have to mention this sentence, provided the physical conditions do not change here now. What are the physical conditions? टेम्परेचर रहने का और कनेक्टिंग वायर का साइज चेंज नहीं होने का बीच में. The resistance change हो गई तो temperature will be increases over there. If resistance is increased, sorry, temperature increases, resistance will increase. If temperature will decreases, resistance will decreases. So if the resistance will vary, the temperature will vary. If the temperature is vary, the current and voltage will not be proportional. So for that reason, the current and voltage should be proportional if the by provided the physical conditions do not change here. Physical conditions, those are only side change, size change nahi hone ka, conductor length should not be changed, area should not be changed, the temperature should not be changed. According to this statement, we can say that one, I is directly proportional to V or V is directly proportional to I. Some 2-3 members they have told that one, V is directly proportional to I, or I is directly, current is directly proportional to the voltage, or voltage is directly proportional to the current. Both are same only. V equal to IR, you have told that one. This R is nothing but proportionality constant we have taken here now. Here V is directly proportional to I hai na. This proportionality constant is nothing but R we are going to consider, where R is the proportionality constant, that is nothing but a resistance of a conductor. This R is resistance of a conductor. If R is constant, then voltage is directly proportional to the current, or current is directly proportional to the voltage. We can tell that one here. Up to here, if you have any doubts, you can ask me. Everyone, you have told the same definition only. After only you have simplified method, you have told that one, I is directly proportional to V. But you have to mention that one, the physical conditions should be constant or do not change. You can mention that one there. Is it clear?
Yes, sir.
After here. So the Ohm's law statement and Ohm's law formula is V equal to IR. This is the formula, V equal to IR. So some people, they will tell that one, from this formula, I will keep here only. When I will send R into LHS side, it will become V by R. So I equal to V by R here now. I equal to V by R. So same equation we can write, R equal to I will send into LHS side, V by I ho jayega. So this is V by I also. Some people, they will, whenever I will ask the Ohm's law statement, it is a product of current and resistance is directly proportional to the voltage. Like that they will tell that. Voltage is directly proportional to the product of current and resistance here. Is it correct? According to this formula, they will say, tell the statement here now. And someone told that one, current is directly proportional to the voltage and inversely proportional to the resistance. According to this formula, that is also correct. Some people, they will tell that one, R is nothing but what? R is a constant here now. The ratio of a potential difference to the current flowing through the conductor is equal to the constant. That is also correct here. So some people, they will tell in this form of the formula, they will state that one. From this formula, they will state that one. From this formula, they will state that one. But actual statement is this one, because based on I is directly proportional to V, or V equal to IR only, everyone, they will remember the statement here. No, so the current I flowing through a conductor is directly proportional to the potential difference between the ends of a conductor, provided the physical conditions do not change or constant here. Otherwise, by keeping the temperature or size of the conductor constant, ऐसा भी बोल सकते हैं. In general also you can write down that one. If you understood the statement, you can tell that one directly. The current flowing through a conductor is directly proportional to the applied voltage by keeping the conductor temperature and size constant. ऐसे भी बोल सकते हैं. So, but you have to remember this formula, V equal to IR. This is up to the end of this syllabus. You should have to know this formula. Ohm's law बोल दिए तो this formula should come in your mind. V equal to IR. This formula you remember, then I equal to V by R equal to V by I. We can write easily, rearranging the equations. LHS to RHS, RHS to LHS. We can write V formula, we can write I formula, you can write the R formula. Is it clear?
Yes, sir.
Okay,
Yes,
you
sir.
Yes,
note
sir.
it down, note it down. Write the statement here now. Ohm's law, you take the heading. Next heading, you take the small heading, statement. First, you take the Ohm's law heading. Next, you take one small heading, that is statement. And write down the statement. The current in bracket I, the current in bracket I flowing through a conductor, the current in bracket I flowing through a conductor, is directly proportional to the potential difference in bracket you write down applied voltage V, in bracket applied voltage V, close the bracket, applied voltage V, close the bracket, between the ends of a conductor, between the ends of a conductor, comma, provided the physical conditions, in bracket you write down example temperature, size, area, etc. Example temperature, size, etc. bracket close, do not change. Full point here now. Do not change. Full point. Abhijit. What is your roll number?
Sir, G56. Sir, sorry, I will name it.
I have waited nearly 10 minutes. I have not admitted into the meeting you because of this one only.
Yes, sir, I'm totally forward. Sir.
Should not repeat once again.
Okay, sir.
Okay. Do not change. Full point. So next line write down that is I is directly proportional to V or V is directly proportional to I. In the box you write down these two formula. In the box you write down I is directly proportional to V is directly proportional to I. Next line, therefore 3 dots रखो, ने triangle का फॉर्म है 3 dots, therefore dots रखते ना ऐसा 3 form, therefore V equal to IR, V equal to IR, V equal to IR, IR, or I equal to V by R, I equal to V by R, or again or R equal to V by I, R equal to V by I. Again, next line you write down. Again, next line you write down. Where R is the proportionality constant. Where R is the proportionality constant, or resistance of conductor. Resistance of the conductor. R is the proportionality constant or resistance of the conductor. Full point. Up to here, if you have any doubts, you can ask. Is it clear? You have to tell me that one. किसी को कुछ भी doubt है तो पूछ सकते हैं इधर तक. We have any doubts? Yes. Is it audible?
Yes, sir.
हाँ. Any doubts?
No, sir.
No. समझ में आ रहा है ना?
Yes, sir.
Okay then. Okay then. Okay. So you have to remember these formulas. एक formula इसमें कौन सा भी एक formula, any one formula you remembered, then easily you can write other two formulas here now. So based on this one, I will take some formulas. We can tell that one. Otherwise, it simplify means that provided R is kept constant, current is directly proportional to the potential difference across the ends of a conductor here now. Means the same Ohm's law derivation only, Ohm's law equation only, they are telling that one in simplified form. It simplify means that provided resistance is kept constant, this resistance को constant रखने का, then current flowing through this circuit is directly proportional to the voltage across the conductor. These two conductor के बीच में voltage दिया है ना, that is directly proportional. We are going to tell that one. If resistance is constant, because of this voltage some current will flow, that is because of this voltage only current will flow, so this current is directly proportional to V. I is directly proportional to V. We can say easily that one here now. So take this one also. The next line you write down. Next line, it simplify means that it simplify means that provided resistance you write down, provided resistance in bracket you write down R, capital R. Provided resistance bracket R, capital R, bracket close, is kept constant, is kept constant, is kept constant, is kept constant, comma, current I is directly proportional to the current, in bracket you write down I, current I is directly proportional to the potential difference V. Potential difference in bracket you write down, potential difference in bracket you write down capital V, bracket close, potential difference V across the end of a conductor, across the end of a conductor, across the end of a conductor. So it is the simplified explanation of the Ohm's law here now. You have to write down the current flowing through a conductor is directly proportional to the potential difference applied between end of the conductor by provided physical conditions do not change, or physical condition should be constant. Like that you can tell the statement. In the last you have to write down V equal to IR is the formula of Ohm's law. V equal to IR is the formula of Ohm's law here now. So example, we will take that one. We'll take one example here now. This is the circuit here now. Take a simple electric circuit as shown in below figure is nothing but this is the figure here now. So applied voltage V equal to 5, we have 5 volts, and R is equal to 100 ohms we are going to use here now. R equal to 100 ohm use किए, V equal to 5 use किए, ये current कितना है मालूम करना है. What is the formula? V equal to IR. We know the formula here now. I equal to what? What is the unknown here now? V is given, R is given. What is the value of formula for I? I equal to V by R.
V upon
V by
V
R.
upon R.
V upon R. V is 5 upon 100. R is the 100 here now. So 0.05 ampere or G50 milliampere also we can write down here. So this is the simple example here now. Simple example. Take this example. Example you write down. Example you write down. And take this circuit diagram. And up to here you write down. Complete it. By applying Ohm's law, V equal to IR. V value they have substituted as 5. I we have kept as it is. R we have substituted as 100. Then I will take right as it is here now. 100 will send into opposite side. Then 5 by 100 is nothing but I equal to 5 by 100 here now. 5 by 100 is nothing but 0.05. The unit of current is ampere. The unit of current is ampere. So I equal to 0.05 ampere we have written here now. After completing this right up part, you just say me, just inform me. Over.
yes, sir.
Yes, sir.
Sure.
Some people just a minute they are saying. Very simple is there. You remember once again you look at this formula. I will give simple type of problems I will give just for you peoples. You can solve that one. Next slide. See, participants I am seeing 53, but the numbers in the chat box 62 messages are there. They are sending their roll numbers. 62 students they have sent as a present here now. I will not give all presents over there. I have my own strategy according to that one only. Who will attend complete class? I am going to give the attendance. Over.
Yes,
Oh,
sir.
Yes, sir.
Okay. Next, what we will do? Some examples we will take that one. We just write that one. If I equal to 5 ampere and R equal to 10 ohm, then find V. Find V here now. See, these are the 3 examples I'm going to show you. All 3 examples are all 3 problems to solve it. All 3 to solve it. I'll give 5 minutes time to just solve the examples and let me know the answers. So these are the 3 examples, simple examples you may get. If the online exams are there, then they may give like these problems. So for that reason, I'm taking the examples for this one. So by considering the first example, you just consider the first example. If I equal to 5 ampere and R equal to 10 ohm, then find V. Anyone, can you tell the answer?
50 volt.
50 volt.
50 volt.
50 volts. Everyone is saying 50 volts. Any other answers are there? किसी को अलग है क्या answer? You can tell also.
No, sir.
No.
No, sir.
Everyone got 50 only. So simply, according to Ohm's law, the formula itself, it will say that one V equal to IR. I is given, R is given, I equal to 5, R equal to 10. The product of current and resistance is nothing but 5 into 10 is nothing but 50. So that one only we are going to, the 50 is the correct answers here. Now we know that V equal to IR, then V equal to I का formula value है 5, R का है 10. So 5 into 10 is nothing but 50 volts. The second example is, if they have given V equal to 21 volts and R equal to 7 ohm, find the current. So the current you have to find out here now. Anyone tell the
3
answer?
ampere.
3 ampere.
Ampere.
Some are 3, some are 2, 4. I heard that.
3 ampere, sir.
Yes, sir. 3 ampere.
3.
3 ampere, sir.
3 or 4. 3 or 4.
3, sir. 3.
3 ampere.
Okay, okay. Very good, very good, very good. I equal to, so we know that one, the formula V equal to IR, we know that one. Here what we have to find, I we have to find. I equal to V upon R, V upon R. V equal to 21 divided by 7. 7 3 is nothing but 3 only here now. Roll number 20, he is joining now. I think some network issues are there. Okay. So 21 divided by 7 is nothing but 3. That is correct, 3 ampere. So don't miss the ampere A symbol here now while writing the examination. Units are very important. 1 marks is clear. 1 nahi to half marks. The unit you have to write down correctly here. So I equal to V by R, the formula from this one we have derived I equal to V by R. Then I equal to V equal to 21 and R is 7. 21 by 7 is nothing but 3 ampere. Simple problem we have taken here now. Next one, third one. If V equal to 10 volts and I equal to 2.5 ohm, then find R. Find, you have to find the resistance here now. Anyone give the answer?
4 ohm.
4
4
ohm.
ohm.
4 ohm or 40 ohm?
4,
4
sir.
ohm.
4.
Okay, so only some students are only, they are very interested and they are giving the answer. My expectation is every one of you should give the answer. Every one of you should give the answer here now. So here V they have given and I they have given. From this formula V equal to IR, we can derive the formula for R equal to V by I. V upon I, we can tell that one. V equal to 10 volts they has given, so 10 we have to substitute. I is 2.5 they have given, 2.5 we have to substitute. It is not ohm, this is ampere, na?
Yes, sir.
This one mistake happened here. So R equal to 10 divided by 2.5 is nothing but 4 ohm. That is correct answer here. So these are the simple problems we have taken here now. They may ask for the 1 marks question in the MCQ and all the things here. So these are the simple. So it completes the Ohm's law, I think. Ohm's law, it is going to complete here now. Next, what we are going to discuss here now. Just a minute, it is not going outside. So electrical conductivity of a conductor. Electrical conductivity of a conductor here now. So electrical conductivity of a conductor we have to discuss here now. This is the simple diagram we have considered here now. See here, this is the conductor we have connected here now. This is the connecting wires. This is main conductor we have considered here now. Here some free electrons are there here now. Whatever the violet colors are there, they are the free electrons we are going to consider here now. There are some free electrons are there. They always, the free electrons always, they will flow from negative to positive here now. They will create one path over there here now without any supply. The applied voltage is 0, then also in a conductor some free electrons are there. They will make a path from negative to positive. They are going to path over there. Whenever we'll apply the voltage over there, whenever we'll use supply voltage, then what will happen? The potential difference, it is nothing but electromotive force. We are going to call that one. Voltage is nothing but electromotive force. We are forcing the electrons in to flow from positive to negative in a required path. The current will start to flow here, no? But while the current is flowing, some opposition is there from the free electronics here now. Some opposition is there from the free electrons. That opposition is known as, we are going to call that one as a resistance here now. इसका current flow होने के लिए some opposition is there. That one we are going to call as resistance. We are going to consider that. We are going to consider that one as resistance. Is it clear? The free electrons, कौन सा भी एक कंडक्टर ले लो उसको, उसमें free electrons रहते. That free electrons is nothing but, example I will take in the pandemic situation of the whatever that one some people should consider that one. Without any rules, no lockdown and all the things, what will happen? Freely they will move over there. Freely they are going to move over there. But during the lockdown, suddenly the polices also, they are freely, they are moving over there. But to purchase something, some opposition is there from the police in the during the lockdown, means the force is applied over there. That force we are going to, whatever the opposition is there, that is resistance हमने बोल सकते हैं. Freely some कौन सा भी एक, suppose one wire ले लो, उसके अंदर some free electrons are there. So we have to pass the current. We have, once we applied the potential difference or applied voltage, the electromotive force is applied. Because of that force, all the electrons, it will create a path from positive to negative. But while creating the path to flow the current, some free electrons are there. They will oppose each other. ये electrons, O electrons opposition will be occur. That opposition we are going to call as resistance here now. That one I will read here. Free electrons flow from negative and a negative end towards positive end. Negative end say towards positive end, they are moving over there. During its travel, free electrons faces opposition from another atom or molecules here now. Whatever these free electrons are there, they will faces opposition by molecules or free atoms. We are going to call that one. Another atom ka opposition रहते. During its travel, free electrons collides on another atom, but still it completes its path from negative end to positive end here now. It will collides with that and it will create a path from negative to positive के बीच में, it is going to create a path over there. So this opposition offered to the free electron is the property of substance. Property of substance is nothing but property of the material. We are going to call that one. Resistance is nothing but what? Resistance is a property of material. Can you tell me, anyone? Can you? So that opposition we are going to call as resistance of a substance. Resistance of a that material we are going to call that one here. So can you tell me the difference between resistor and resistance? Anyone? What do you mean by resistor and resistance?
Sir, resistor is electrical element and resistance is its property.
Okay, very good, very good, very good. That one only we are clarifying here now. It is resistance is the property of the material or that element or that circuit or device. We are going to call that one. Circuit element we are going to call that one. Resistance, inductance, capacitance. These are the three basic circuit elements we are going to call. So the resistor is a circuit element. Resistance is the property of that circuit element. We are going to call that one. So that property of resistance, it has, which is the opposition of the substance. We are going to consider which substance or which element has some opposition. That one we are going to call as resistance here. This diagram, the लेने का intensity, you should know that one. How? See here. See this one element or atom or molecules or electron is flowing here. This is violet color. free electrons are there. See, some oppositions are there. The both are traveling from opposite side only. If two persons are facing each other in a single walking place, they are opposing each other. So that is whatever the opposition will occur by these elements, that is called, it is a substance, sorry, property of the substance. That one we are going to consider as resistance of the material. We are going to consider here now. Based on this, we are going to define the resistance here now. So can you take this diagram and this explanation, all of you? It is very important to understand the resistance and how the currents are flowing here now. What is the importance of the potential difference here now? When the applied voltage will be applied, the electromotive force will be applied to the free electrons. They will create a path from positive to the negative here now. The current will always flow from positive to negative outside the applied voltage, supply voltage, and inside this one source, it will negative to positive, it will flow here. Take this diagram. Here this is the conductor, here the voltage, and this is the whatever the red arrow mark is there, that is current I here now. Note down first. Take the heading electrical conductivity of conductors. You can take the heading as electrical conductivity of conductors. Then you take this diagram. After completing this diagram, you just let me know. I will read this one and you can write down. Diagram हो गई तो बोल दो मेरे को. Over Shubham More. More Shubham. Shubham More, unmute. Roll number 50. Shubham More. More Shubham. What is the time now? लेक्चर कब स्टार्ट हो गए? So which lecture you are attending here now? 2 to 3 or 3:15 to 4:15? Don't do that one. Okay. Anyhow, I am not going to give the attendance for you. At least because only 2 minutes time is left. I'm not going to give the attendance. Okay. To take this one, you will take this in a write down. All of you write down because of some neighbor. They are running some motor and all. They are getting disturbance. I'll mute. So you take this one, we'll stop here and we'll continue the definition and all the things in the next class. I will take the attendance.